Hi everyone, welcome back to the channel, and today we solve Leetcode daily challenge problem number 49, group anagrams. It is tagged as a medium problem. It's rather an easy problem to solve, and we'll check out the problem statement first, then we'll look into the approaches which we're going to use, and towards then we'll see the code as well. And just a sneak peek, we will be discussing two approaches to solve this problem. So starting with the problem statement is given that given an array of strings, group the anagrams together, you can return the answer in any order. Okay, an anagram is a word or phrase formed by rearranging the letters of different word or phrase, typically using all the original letter exactly once. So basically we will be given an array of strings, and we have to group all the anagrams together, and they have defined what is an anagram. So basically eat and t are anagrams. Why? Because you can make either of these using the same set of characters. Okay, for example, if you had one a, one e, and one t, you can create, or you can make any of these two. Okay, so that's why these are the anagrams. So we can use multiple ways to solve this problem, but mainly we'll be discussing two of those. So first solution or first approach will be using sorting of characters. Okay, so first way is using sorting of characters and having them in hash, and other one is using 26-bit array. So we'll discuss both of these one by one. So I have taken the same example in which we have e, t, tan, 8, nat, and bat. And in approach 1, what we are doing, we are taking each string one by one, and we are sorting the characters. For example, if you sort EAT, it will give you AET, because the ASCII code of A is smaller than E, and so on and so forth. So if you sort these three, E, T, and 8, you're getting the same key, right? So what you can do, you can pick this and put that in the hash map using this key. Okay, these are the keys, like the sorted strings are the keys. Now if you sort tan and nat, you can again club the both under the same key, which will be ant. Okay, and of course, we have bat, and if you sort this, you'll get abt, and there is no other anagram or anything else which you can made from this set of characters. So that's why it is alone. So once you have this hash map, what you can do, you can just simply take the values of it, and we will be good, right? Other approaches using 26-bit array and hash map. Okay, so like here, what we have done, we have sorted the characters, right? And use the hash map. So in the second approach, in this approach, what we will be doing, we will be basically using the ASCII code. We'll be using the ASCII code of characters to determine if they have same set of characters or not. For example, E, T, and 8, as we have already seen in this approach, that they belong to the same group, or they are anagrams to each other. And if you use 26-bit array, and every index will basically represents uh, the alphabet, I can say. For example, 0 index will represent A, then 1 will represent B, C, D, E, and so on and so forth. So you will basically have how many? 26 indexes. Okay, and as soon as you see E, what you'll have to do, you'll have to find the ASCII code character. That you can do by using order of E. Okay, and to bring that on a scale of 0 to 26, just subtract order of A from it, and you will be good. You can just simply write 1 in it. For example, uh, let's say ASCII character of E was, I'm just taking an example, it was 100, right? But you cannot put that over here, because we have taken 26-bit array. So to normalize it, what we are doing, we are taking ASCII character, ASCII code for A, which let's say is 95, and we are doing subtraction of it. So 100 minus 95, which ends up being 5. So this will be the index which we will update. Okay, so this is what we are doing. So if you do the same for all the all the strings, you can again see that you get this 26-bit array as your key for the hash map. Okay, And again, you can use this as a key and put everything together, and at the end you'll just have to simply return the values from the hash map. So let's check out the code for the same. Okay, first we are starting with, okay, let me uncomment this. Okay, so first solution is using sorting and hashing. So what I'm doing, I'm just simply iterating all the strings we have in the array and we are sorting it, right? So we use the sorted method, which will give you an array, okay, and it will be sorted, and I'm joining it again using join. And after that, we will use that sorted value as the key and have that stored in the hash map. Okay, so it will end up something like this. For example, AET will have 8, EAT, and T, and like, you know, and other group will also be there, and at the end we'll just simply return the results, the values from the hash map. Okay, so let's comment out this one. Like, this was a very simple approach, that's why I am not using this one for the for checking out the test cases. But this one was a little interesting, how we can normalize or how we can bring down the scale. For example, this is using 26-bit array and hashing, and this will be the result. Okay, so you will have your key as 101 and so on and so forth, like how we discussed in the explanation, that with every character you will be incrementing one in the at the index of that character. For example, if we had, just assume that if we had double A's, this value would have been 2. Okay, so this is what we are doing over here. And if you see, we have taken a 26-bit array. We are iterating each character from each of the strings, and we are doing the exact same thing. Like, we are taking the sky character, sky code of current character, subtracting out the sky code for A, and adding one in it, so that it will represent the frequency of each character in the string. And at the end, we are simply taking, the array which we had, and using it as our key, and we'll have all the results in the C as in the values of it. So yeah, this was it. Like, at the end, we are just simply returning the results. Let's check out the test cases. So as you can see, all the test cases got clear. Let's submit it for further evaluation again. And okay, it is taking some time, but yeah, so the solution got accepted. And as you can see, like, we have done fairly well. So we have around 75.71% of the submitted solution. So yeah, thanks again guys for watching out the video. Stay tuned for the upcoming ones. Don't forget to like the video and subscribe to the channel. Thank you.